Section 7.7, we are going to solve right triangles. Before we begin, let's review some of the ideas from 7.5 and 7.6 right triangle trigonometry. So see if you can do these problems where you are writing the ratio for the sine of B and finding some missing side lengths in a right triangle based on those ratios. If you are referencing angle B and you want to write that ratio, first of all, you need to know which side for sine is opposite. And this is the side that's opposite. This is the side that's adjacent, and this is the hypotenuse. And then all we do is fill in those numbers for opposite over hypotenuse. Well, we know the hypotenuse is 10. We don't know the opposite side, but we can use the Pythagorean theorem. This is an extension of the 3, 4, 5. So this is the 6, 8, 10. So this would be the sine ratio 8 over 10, which we'd reduce by dividing by 2 and get 4/5. The cosine, again, adjacent over hypotenuse, so you're taking 6 over 10, which again reduces to 3 over 5. And the tangent, again, toa, opposite over adjacent, so we would get 8 over 6, which is equal to 4 over 3. So that's just practicing the ratios. Now let's see if we can use those ratios to solve. So we want to find G. So to find G, we're going to use our reference angle of 42 degrees, and we know G is the side opposite, and we are also given the adjacent side. So we have to use the OA, or TOA ratio, to take the tangent of 42, and that's always going to equal the exact same decimal ratio when you divide the side opposite, which is G, over the side that's adjacent, 19. So now I can just multiply each side by 19, and so now I'm going to have my G value is equal to 19 times the tangent of 42. And so when I multiply that together, that should give me my G is 17.11 units. Now at this point, I have two options for finding that hypotenuse. Since I know G now is rounded to 17.11, I simply could use that information and use the Pythagorean theorem. But if you use the Pythagorean theorem and your G value is incorrect, you will automatically get the hypotenuse incorrect as well. So sometimes it's helpful to just set up a ratio for H now. If we're finding H, that side is the hypotenuse that we're trying to find. So I know what I'm going to use is the given side, again, in case G is wrong. So I'm going to use the ratio of adjacent and hypotenuse, which is ka. So I'm going to set up the cosine of 42 equals 19 over h. And here's where I can exchange those means. Again, if that makes sense to you. Otherwise, put a 1 under this and cross multiply, or switch those around. And that gives you that h is going to equal 19 divided by the cosine of 42. And so our h value is approximately 25.57 units. So just a little quick review of what we've done before we move on. And so we're going to have to look at, we're going to use the inverse trig ratios to find missing angles now. Before we were only finding missing sides, now we're going to find angles, and then we're going to use that to solve a triangle, which means finding all the missing sides and angles. So if you think about what's the opposite of addition, subtraction. What's the opposite of multiplication? Division. What about the opposite of squaring a number? Square root. And the opposite of taking the tangent is taking inverse tangent. That's called inverse tangent, not tan to the -1. So we call these opposites inverse operations. So the inverse operation for tangent is inverse tangent, etc. for sine and cosine. And on your calculator, your inverse trig ratios are right above your sine, cosine, and tangent buttons. So you use the second, and then you type in that like inverse button. So you'll see it will look like inverse tangent when you type in that. So we'll practice that. But here's what's really happening. When you have the cosine of some angle, we don't know what angle this is. But we know that when we divide it, we get the ratio of 0.58. We could start guessing and checking, just dividing some numbers, but that's going to take forever. So what we're going to do is our calculator stores all the ratios for every angle, but we can also turn it around the other way. And we can say, hey, calculator, this is the ratio for some angle. When you divide the adjacent by the hypotenuse, give me the angle. And that's how you use the inverse cosine. And what happens is when you take and set this up, and you have the cosine of x equals 0.58, and we're trying to find that angle, we can take the inverse cosine of each side, and what happens is the inverse cosine and the cosine are opposites, so they cancel each other out. And so then what you're left with is that your value that you're trying to find, x, is equal to the inverse cosine of that ratio. So this piece right here is telling your calculator to find what angle matches with 0.58. So you're telling your calculator what angle has 0.58 as its ratio for dividing the adjacent side by the hypotenuse. And then you'll get the angle measure, 54.55 degrees. And if you go to your calculator and go ahead and type in the cosine of 54, let's say, or even 54.55, that gives you 0.57999, which is our 0.58. So that's kind of the process of what's going on. And that's what one of the things we're adding today with our right triangle trig is our inverse sine or sine inverse, inverse cosine, and tangent inverse. And we're going to use these to find angle measures. So that's the important piece. Sometimes students get mixed up. When do I use the tangent and when do I use the inverse tangent? If you're trying to find an angle measure, that's when you use the inverse. We only use that to find angle measures. So, for example, it says find this angle. Well, for this angle, we are given the side that's adjacent. Oh, sorry, that's not the adjacent. We are given the adjacent side. That happens to be the hypotenuse, however. So this is the adjacent side, and this is the hypotenuse. So that's our A and our H. That's our ka. So we want to know the cosine of some angle x is equal to, we don't know what the angle is, but we know when we divide the side that's adjacent by the hypotenuse, it's always going to give us the exact same decimal ratio, which in this case, you can leave it as a fraction, or the cosine of some angle equals 0.5. What angle is that? So to solve this, what we do is we multiply each side by the inverse cosine. And these cancel out, so we're left with x is equal to the inverse cosine of 0.5. And so on your calculator, you simply type in inverse cosine, and then you could put in 4/8 or 4 divided by 8 or 0.5, and that's going to give you going to give you 60 degrees. So that's how we find a missing angle. Now, of course, once we find the missing angle of 60 degrees, then we know this has to be 30 because of triangle sum. So if you're trying to find all the missing sides and angles, which is what it means to solve, it's easy once you find one of the angles because you already know the other angle is 90. And then if you're given two sides, you can always find the third side using the Pythagorean theorem. So this is really just extending a lot of the things we've already been doing. So first we're going to just practice using some more of the inverse trig ratios to find missing angles. So let's see if you can do the setup on this one. We want to find this angle theta. So what inverse trig ratio will we find, or what is the ratio we're going to set up? Well, 6 is our adjacent side and 20 is our hypotenuse. So we're using the same cosine ratio. Adjacent over hypotenuse is our ka. So we have to take the cosine of some angle, which we don't know, but we know when we divide whatever that angle is, we divide the side that's adjacent by the hypotenuse, we're always going to get a same decimal. And you don't really need to change that into a decimal or reduce the fraction. But what you're going to do to solve, again, is you are going to take and multiply each side by the inverse cosine. So now, again, these cancel out, and so I'm left with theta is equal to the inverse cosine of 6 divided by 20. It just saves us some time there. So when we do that, then our theta angle is 72.54 degrees. I don't remember if I put degrees on the last one, but include your units. Okay, so now find angle x and y. So I'd like you to try to do this. I'd like you to try to find both of the angles. Again, what I said before is once you find one angle, you can use triangle sum. Or if you want to be more accurate or just double check, you can set up a second trig ratio for the second angle. So I'm going to let you try that one on your own, and then I'll have you check the notes to see if you got it correct. So now it says to find angle R. So we're going to find angle R, but they specifically want us to use the sine ratio to set it up. So the sine, remember, is our so we're going to take the side opposite over the hypotenuse 10. And so to find it, we're going to take the inverse sine, we're going to multiply each side by the inverse sine. Those cancel out, so I get R is equal to the inverse sine of 8/10, and so R is equal to 53.1 degrees. Well, now, if you look at finding it using the cosine, which is ka, now I'm going to take the side adjacent, which is 6, over the hypotenuse 10. So now to solve, again, I am going to take the inverse cosine to solve. Multiply each side by the inverse cosine. So then what that gives me, since these cancel out, is I get the inverse cosine times 6 over 10, and that gives me R is equal to 53.1. And if you go ahead and do the same thing with tangent, you're going to get the same value because R is not changing. It's just how we get it is changing. And so if you take the inverse tangent of 8 over 10, the tangent, TOA, opposite over adjacent, you will also get that R is equal to 53.1 degrees. So that's just showing you that sometimes you can use any of the ratios, especially if you're given two sides, because you can always find the third side using the Pythagorean theorem. Okay, so now let's get into solve the triangle. When we say solve the triangle, what it means is to find all missing sides and angles. That's what it means to solve. Well, I'm given a 37-degree angle, so I can use triangle sum to find that angle P is 53 degrees. Okay, so we found all of the angles. We're only finding missing, so angle P is 53 degrees using triangle sum. So the other sides now that I need to find is I need to find QR. Okay, well, I'm going to use this reference angle right here of R because it's given, and I am trying to find this side. I'm just going to call it X, or QR, and so that is the side that's adjacent to angle R, and this is the hypotenuse, so that's our ka. So I'm going to take the cosine of that 37-degree angle and set it equal to X over 22. So now I can simply just multiply each side by 22, or you can cross multiply, but so now my value of X is equal to 22 times the cosine of 37. And so that gives me 17.57 units. So that means QR equals 17.57 units. I also need to find, though, QP right here. And actually right here, you could use the Pythagorean theorem again because you already found it. But if you're unsure, if like you're taking a quiz or a test, if you've gotten the QR part wrong and use the Pythagorean theorem, automatically your QP will be wrong. So again, sometimes it's just best to do a new ratio. This is the side opposite. So now if I use opposite and hypotenuse sine, I can set up the ratio that the sine of that 37-degree angle is equal to dividing the side opposite over the hypotenuse. And when I solve, that gives me y is 13.24 units. And you can do the math and double check, but that means then that QP is 13.24 units. That's what it means to solve the triangle. All right, your turn. You try this one. Work through trying to find the missing angles and sides, and then check back to the notes to see if you've done it correctly. And then we're going to move on to a word problem. You lean a 20-foot ladder against a wall. The base of the ladder is 4 feet from the wall. What angle does the ladder make with the ground? So we have a wall and we have a ladder. And it doesn't matter if your picture is not that accurate, but this is our wall, okay? And it says that the ladder is 20 feet. So this ladder is 20 feet long. And we want to know what angle does the ladder make with the ground. So we want to know this angle right in there. That's what we're trying to find. I'll just call it theta. We also know that the base of the ladder is 4 feet from the wall. So that's the picture we have. And of course, the wall makes a 90-degree angle with the ground. So we can use trig. And the wall is the side opposite. So we can take opposite over, well, the wall is, we're not trying to find the length of the wall. Sorry. We are trying to find the angle. So I went back to reread the question. What angle does the ladder make with the ground? So I need to find this right here. So I need to find, and what I'm given is this is an adjacent side to that angle, and this is the hypotenuse side. So that is our A and our H. So I'm going to use ka, and I'm going to say the cosine, find the cosine of whatever angle that is, but I know it's equal to dividing the side adjacent over the hypotenuse. So now again, to solve this, I need to use the inverse cosine, multiply each side by the inverse cosine. So again, these things cancel out. And so what I'm left with is that theta is equal to taking the inverse cosine of 4 over 20. Again, you don't need to reduce the fraction or get a decimal there, but you're trying to tell your calculator, hey, what angle matches the ratio of 4/20ths? And that gives you a 78.46 degree angle. So theta is 78.46 feet. And that is the end of section 7.2.